Okay, now let's think about type 2 error probability. Type 2 error was defined as you do not reject a wrong null hypothesis. So your hypothesis was wrong, but if you fail to reject it, then that is another error, type 2 error. So then type 2 error probability is basically probability of not rejecting the null hypothesis. Null hypothesis is not rejected when the sample average lies between the critical values. And we know the critical values, so its probability is probability that sample average in between those two numbers. And another thing you have to consider here is, here I assumed that the null hypothesis is wrong. But like when I say null hypothesis is wrong, it just means mu is different from 81. It can be like 90 or 100, any number different from 81 can do. So we have to specify a specific value. Like here as an example, we are going to consider 82, but you may use 83, 84, like 1000, 1 million. Any number can be substituted here, right? So but like, and that's so I will show you how to derive the probability with this number. And then given this setup, you can calculate the probability of type 2 error as the probability of not rejecting the null hypothesis, or the probability that the sample average lies between the critical values, within the critical values, under the assumption that the true mean is actually 82, right? So the null hypothesis is wrong, but it is not rejected. Then let's see how we calculate this. Idea is the same. We are going to use the same sampling distribution, but the difference here is this part. Now the mean parameter is 82 because that's what we assumed. When you calculate type 1 error probability, it was 81 because at that time we assumed that the null hypothesis was correct. But now we assume mu is 82, so you have to use your assumption, right? And then using those two parameters, the standard deviation is the same. Standardize x bar and calculate the probability. So probability can be standardized x bar transformed into z, standard normal distribution, and then two numbers are transformed in the same way. Subtract the mean and divide by the standard deviation. And then now you have a different number. The resulting numbers are not the familiar ones. So earlier you had plus minus 1.96, but now it's not a common number. So you have to calculate this probability from a normal distribution calculator. Use a calculator, a program, whatever, and calculate this probability. We learned how to calculate standard normal distribution probability in chapter 6. Then the result is 48%, about 48%. So there is a very high probability of not rejecting the null hypothesis, right? So 48% may be higher than what you imagined. What you can learn here, so that the algebra uses some basic techniques we learned earlier, and what's important here is you have to remember this definition. Think about what is a type 2 error. If you know it happens when you do not reject, then that's the clue to calculate the probability. And what you can learn from here, the probability depends on the value you assumed. So we assumed 82, but if you used a different value, then this part will be different. 82 can be replaced by any other number, like other than 81, any number not equal to 81, then these numbers will be different. And then the probability will be different. So type 2 error probability depends on where you assume, what value you assume. And the intuition here is type 2 error probability will increase as the value you assume is similar to your null hypothesis. So for example, the correct dose is 81 milligram. And suppose that there are two fake drugs. One has an amount of 82 milligram, and the other has an amount of 100 milligram. In this case, 100 milligrams will be clearly different from the original drug, right? So it will be much easier to detect the fake one. So as a result, your type 2 error probability will be very, very low. You can tell this is wrong, right? But if the fake drug is similar with the original one, authentic one, then it is hard to detect the fake one. If you fail to detect what's fake, what's wrong, that is type 2 error, right? Because type 2 error happens when you do not reject a wrong hypothesis. So if a drug is actually has a wrong amount, then you had to reject it. But if you fail to reject it, that's type 2 error, which is more likely to happen when the fake is more closer to the hypothesis. So if the difference is smaller, then there will be higher probability of type 2 errors, right? That's one thing I want you to realize. And another thing is that type 2 error probability also depends on alpha, but there is no explicit relationship like type 1 error probability. So the idea is the rationale is the same. Type 2 error happens when you do not reject the null hypothesis. So, and earlier I said when alpha increases, you are going to reject more. So when you reject more, type 2 errors will decrease. So because when you reject, you are not going to have type 2 errors, right? So it's a kind of trade-off. If you increase alpha, then type 1 error will increase, but type 2 error will decrease. So it's a trade-off. Okay, so here's a comparison here, and then there is a trade-off. How can we balance? Here, traditionally, conventionally, usually type 1 errors are considered as a more serious error than type 2 errors. So usually you would like to reduce type 1 errors rather than type 2 errors. So this is also consistent with the attitude of hypothesis testing that favors the null hypothesis much more than the alternative hypothesis. So the null hypothesis is favored, so we do not want to reject it by mistake, right? Therefore, we put it under control by choosing the significance level. So significance level equals the type 1 error probability. So choice of the significance level can be thought of as a choice of how much you are going to sacrifice type 1 error probability. It cannot be 0. If type 1 error probability should be 0, that means you cannot reject at all. But say you have to sacrifice a little bit. Say if you are willing to sacrifice, if you are going to allow 1% of type 1 error, then use that as the significance level. An example of this attitude is like this. There was I don't know, like an English judge and politician in the 18th century, Sir William Blackstone, he said it's better that 10 guilty persons escape than that one innocent suffers. So I would be more generous. So the null hypothesis is that the defendant is innocent. So you should respect that much more than catching the criminals, right? So the trade-offs are seen here, right? And I'm going to give you another example for your exercise. Now we are going to apply those steps to different dose. So it's a larger dose aspirin which contains 325 milligrams. So like structure is the same. We are going to consider null hypothesis at this value. So we are going to consider mu is 325 null hypothesis in the null hypothesis, and the alternative hypothesis is negation of that. And all the other numbers are the same. Standard deviation is 5, sample size is 100, significance level is 5%. From this, we are going to find first step, you need to find the critical values. And then we are going to calculate the type 1 error probability, and then type 2 error probability, and then we will see what happens if alpha changes. So we are going to study them step by step. And these steps are what you are going to use in doing the homework. in doing the homework. So first, what are the critical values? Use the numbers I gave you earlier. Right? Pause the video and try it by yourself. The answer is like this. The null hypothesis value is 325, and you allow plus minus 0.98. So this part is the same as before because alpha is the same, standard deviation is same, sample size is the same. So the only difference is mu zero. Only mu zero changes from our earlier example. All the other guys are the same. So the numbers are given like this. Using those numbers, plug in, then you will obtain these results. So I will use these critical values for the calculation of error probabilities. And then, given the critical values, what is the type 1 error probability? And there is another option, cannot be calculated because the value of x bar is not available. Choose one, calculate if you need do the math, and you may use calculator or Excel. Okay, the answer is 5%. You do not need any algebra because I said type 1 error probability always equals the significance level, right? You do not need any calculus, any algebra at all. Just when I ask you what is the type 1 error probability, you can just find the significance level. That's it. This is it. And now type 2 error probability. It's not easy. So as a preliminary step, first let's think about, we are going to calculate the type 2 error probability, and which guy it captures the probability of type 2 error or probability of not rejecting the null hypothesis. So remember, type 2 error happens when you do not reject a wrong null hypothesis. Then what is the probability of not rejecting the null? How can you represent that? The answer is A. A is the answer because you do not reject if the sample average is within the critical, between the critical values. So A is the probability of not rejecting the null hypothesis. Okay, then given this probability, we can write it this way. Type 2 error probability is written this way, and what you additionally need to assume is the true value. What is the actual value of the if the null hypothesis is wrong. So we are going to choose 324. So we, in our null hypothesis, we believed the mean is 325, but actually the truth is 324. Then, given this number, find the type 2 error probability, right? I'm going to stop the video here. So in the next video, I will show you the answer. And between those two videos, please do this exercise. And see you in the next one. Bye.